Hello. This is going to be number 4. Write the domain in interval notation. I think two things might scare you here. One is that it's saying the domain, and you're like, what? And the other thing is interval notation. And you're like, well, of course, I'm familiar with what write and the and in mean. Okay, but the domain means values for x that will work, right? Domain has to do with x values that work. Range has to do with y values that work. So the only way that x values are not going to work here is if this becomes 0, right? We've done a bunch of these problems where having this be 0 is our no-no, so we just tried to figure out what would make this 0, and we completely ignored the top. Hey, we're going to do that again, like nobody cares what the top is, it doesn't matter. But this can't be 0 because we can't divide by 0. That just doesn't work out, doesn't make any sense. So we're going to try and figure out then x squared minus 5. How can we figure out what that is equal to 0? The other part of this I think could have confused you is that I don't know if you did any problems like this in class, but you didn't do any like this with me, where we used, of course we're going to use the x's, but you used the square root of something to have this work. So like we do root 5 both places, which means that this last one, 5, the square root of 5 times the square root of 5 is, 5. And to make the middle drop out, we do what we usually do. We go plus and minus. So x squared minus 5 minus x root 5 plus x root 5 cancels each other out. And at the end, the square root of 5 times the square root of 5 is 5. Right, that undoes itself. So to figure out what would make these things 0, it used to be easier and we just had regular numbers, but we can still do it. So to make it 0, it would be either minus root 5 or it would be root 5. Those are the things that would make it 0, and so they can't be in the domain. The other part that might have worried you is this interval notation. Because when we're working in the computer, it sets up for you, basically, the kind of way that it wants you to explain the answer. I already have mine, just to start us off here, in order, right? Negative root 5 is smaller than root 5. And what we're trying to show, if we do the number line, is that we can't have negative root 5, and we can't have positive root 5, but everything else, is cool, right? Everything else is cool. Those are the only things that would make this 0 and would mess up the x values so they can't be in the domain. So in our interval notation, we're going to start all the way down at negative infinity, and that's going to go up to negative root 5, right? And we won't include that. That's going to be in union with, another piece of it's going to be negative root 5, comma, root 5, because we're taking that out, but we have everything in between those, right? That's everything in here. And finally, we're going to have a union with, not included, root 5, positive root 5, comma, positive infinity. And you just don't include infinity because you're too small to include infinity and hold it in your hands. So our final answer is all this down here, negative infinity, leaving out negative 5, union, so adding on this little area between negative root 5 and root 5, negative 5, root 5, and 5, that, not including those, but in between them, and finally uniting that with this end, which is the root of 5, all the way up to positive infinity.